A couple requests for finding equations from graphs and tables without a calculator. So looking at your table, the first thing you want to do is first check your input versus output. So what is X and what is Y? So input is your X value, output is your Y value. Remember, X is also independent, and then Y is going to be dependent. So independent variable, dependent, because Y depends on what we plug in for X, which X value we go to look at. Another great call out just while we're looking at this table is we want to remember that when X is 0, that means I didn't go left and right. I just went up or down. In this case, I went down. That is always going to be your y-intercept. From the ed puzzles this past week, the two things we have to write the equation is going to be your slope and your y-intercept. Again, slope can also be called rate of change, which I'm going to abbreviate, rise over run, coefficient of X, and then y-intercept could also be called starting point. And it is also our constant, the number with no variable. Just again, some more vocabulary checks since we're going over some basic stuff. But from a table without a calculator, you want to see how did I get from the first to the second. So from 0 to 1, I got there by adding 1. So 1 to 2, adding 1, 2 to 3, adding 1, 3 to 4, adding 1. And you want to check this because if they aren't evenly distributed, then you are going to need to use your calculator possibly and get a line of best fit, which is still the same idea, but when it is consistent, we can get after it. So from -8 to -5. So I owed you $8 and now I only owed you $5. That means I paid you a +3. When I owed you $5 and now I only owe you $2, again, I paid you a +3. I owed you $2. Now you have an extra dollar. Again, I paid you $3. You have $1 and you got to $4. Again, that's +3. And you do want to check all the way through. Remember, it's rise over run. So rise is our y value over x. So our y value in this case is 3 and our run is 1. So our slope, our m, is 3 over 1, also known as 3. We already identified our y-intercept because that is where x is 0. So we have our y-intercept and we have our slope, and you can now write the equation of this line. And you want to always write it in slope-intercept form unless they tell you otherwise, or if the conversation doesn't lend that to be the case. So y equals, our slope was 3, plus, or we in this case it's a negative, so you can do plus a -8, or we could write -8. Now there was a couple people on ed puzzles and things along the way that left off the x. If there's no x there, it is incorrect. The format of this matters big time. Now, when I ask for the slope is 3, not 3x, because the x is the input. So again, very specific. You want to keep it nice and neat. All right, I'm going to go to the next one. First two, I kept it pretty easy. So from 1 to 2, 2 to 3, 3 to 4. Consistently increasing by 1. From $3 to $1 means I spent 2. Spent 2 again, and I spent 2 again. Rise, so y over x, so rise over run, y over x. It's a -2 over 1. So again, it's going to show up just as a -2 whole number for your slope. Your y-intercept, in this case, is not there already, but 4, 3, 2, 1, this could easily be our 0. And as we were subtracting 2 going down, if I add 2 going up, that would make my pattern continue. 5 minus 2 is 3. And so now I've found my y-intercept. So again, at that point, you have your slope and your y-intercept. You want to write that equation. -2x, it is a negative slope. X is the input, y is output, plus your y-intercept, which is your constant, your starting point. And remember, your y-intercept is where x is 0. Now, this guy's a little wonkier. He gets a little more excited. So from -2 to +1 is definitely not a +1. 1 to 4 and 4 to 7. What I like to do is find the pair that makes the most sense to me. So 4 to 7 is going to be 3. 1 to 4 is 3. And negative 2 to 1 is also 3 if you're thinking about your number line. If I owed you $2, I would have paid you 3 to have you sitting at a positive 1. Now, from 10 to 1, I subtracted 9. From 1 to negative 8. So if I had $1, but now I owe somebody 8, that means I spent 9 again. And from negative 8 to owe you a negative 17, I had to borrow 9 more. Rise over run, so negative 9 over 3. We're in high school. We always want to reduce. 3 goes into 9 3 times. So it's going to be a negative 3 over 1 because I divided them both by 3, which again is going to give us a negative 3 as our slope. So that's our m value. We are missing our y-intercept. Now, you can again count. It's going to fall somewhere in the middle of here, so you can't actually count back. I'm sorry. It's going to fall in the middle. It's going to fall 1 and then 2 up. So up to you, which is easiest for you to do, but 1, 1 is a pretty easy coordinate. So if I plug in 1 for the y, negative 3 for the x, I'm sorry, for the slope, and 1 for the x, I can solve for my y-intercept. So I can use tables to do the same thing. So again, this was just our slope, and I'm using this coordinate 1, 1, and I'm going to solve for b. So 1 equals a negative 3, because negative 3 times 1 is negative 3. We're going to great divide, solve for b. That's a negative 3, add 3. So b is going to equal 4. So b will equal 4. All right. So then in that case, we have our slope and we have our y-intercept. Y equals negative 3. Don't forget your x plus a positive 4. You also, if the algebra way, this way doesn't work for you, but the idea of a table does work for you, it is changing negative 3 every time. So I could take my negative 2 from right here where I have 10, and then I could do negative 1, 0, and we have 1, which is 1. So if I subtract 3 from 10, I get 7. And if I subtract 3 from 4, from 7, I'm going to get 4. And there is our y-intercept as well. So if you wanted to do it graphically, you can't get out of solving for slope, rise over run, and making sure you can reduce, but you could get out of doing it algebraically by extending your table out, since it is jumping. As you can see, 3 over negative 9, or negative 9 over 3. It's going every 3 for x. So that's another way to do that. Now, there was a call out to graphs. The two things we need, again, is slope, which is your rise over run, and y-intercept. Y-intercept is simply where it crosses the y-axis. So you do want to make sure you're looking at your y-axis. In this case, it's a negative 1. Our slope, we want to count our rise over run. So it's good to find another couple good points. There's 1, there's 1. And mine's a little harder to see because the graph didn't print. But I'm going to go up 1 over 2. Up 1 over 2. And I can check it again. There's another one. So that over 2 and up 1. So rise, run. Rise 1, run 2. I then stop and decide, is this a positive line or a negative line? It is positive, so our slope is going to be positive. So again, I now have my slope and my y-intercept. So y equals 1/2 x minus 1. Last graph here. Again, you want your y-intercept. So you want to look at your y-axis. In this case, it's a negative 4. Then we need our slope, so our rise over our run. So we want to look for good coordinates. Well, this one's kind of messy. There's one here, here, and I think here, because mine's a little hard to read. But, so at that rate, if I go 1, 2, 3, 4, 5, up, 1, 2. Should be able to do it again. 1, 2, 3, 4, 5, 1, 2. You should get at least a good solid 2 steps. I'm calling these guys steps. So 2 rise over run counts that are exactly the same before you assume you have your slope. Because a couple of us are going to end up thinking we have good points and they're not. So if it doesn't repeat, then that is not correct. So it's a rise of 5, run of 2. Rise of 5, run of 2. It is increasing. So it is going up at the end. So that means it's a positive line. So it's going to be y equals rise over run plus or minus, in this case, because it's a negative, plus a negative 4, or 5 over 2x minus 4. There was a call out to y is the same thing as f of x. It's just function notation. instead of just standard notation. So f of x is y, exactly the same thing. It's just function notation versus not. So think about font changes in, say, maybe like a Word document. All right, a word problem. At the beginning of spring, Shanice planted a small sunflower in her backyard. When it was first planted, the sunflower was 25 inches tall. Remember, you're always looking for a y-intercept, a non-negotiable, a starting when it was first planted. So this is going to definitely be non-negotiable. She bought it at 25 inches. That is not going to change. The sunflower then began to grow at a rate of 0.5 inches, and then you're going to see that per week. So that's where you get your x. Okay, so 0.5 inches per week. And now we have our output, which is going to be our height. How tall will the sunflower be after 10 weeks? Per week, so weeks is going to go in the place of x. How tall would the sunflower be after W weeks? So in this case, that x would be a W. That would be your W weeks, unknown weeks. So our x value, what we're going to control is weeks. What's going to come out of this equation, so it's going to be our output, is going to be the height of the flower. So to check this for 10 weeks, we're going to do 0.5 times 10 plus 25, which should give us 30. So 30 inches tall. The flower is 30 inches tall. Last but not least, just to show a little bit more. Actually, I'm sorry, it's not the last one. We got two more. A baby is born with a weight of 8 pounds. So born with a weight of 8 pounds. Non-negotiable, not going to change. This is our starting point. 8 pounds. So we're going to write the equation. So we need y equals mx plus b. Our b in this case is 8. Never going to change. Baby popped out, 8 pounds. And then began to gain, that's a positive, 1.5 pounds per month. So 1.5 per month is the part where that's your x value, is the per month. And now we have our equation. Now you can use this equation. They want us to fill out a table. So at 0, soon as he was born, what do we say that the starting point was? What was the non-negotiable amount of weight for this baby? It's going to be 8. They gave it to us in the word problem. And then it's going to increase 1.5 per month. Number of months since birth, 0, 1, 2, 3. You can plug these in, or just think about 8 plus $1.50. It's going to be 9.5 pounds. Add another $1.50 because that's going to be 2. And that's going to be 11. Then we're going to do it again, and that's going to be 12.5. Same thing if we were to plug this in, 1.5, and I'll just jump to 3. 1.5 times 3 is going to give me 450, or 4.5 plus 8 will give us 12.5, which is the same way. So this is by table. This is by algebraically, but you have to be able to set this up. So usually it says they were born with their weight, started with, invested amount initially, base pizza, base ice cream. Anything you eat that you would add things to is always going to be your starting number. Now, rate of change and all the good fun things, being able to compare them because you've been doing rate of change for quite some time. All right, again, my graph is a little iffy, so I got a -4 for my y-intercept. So when x is 0, my y-intercept is -4. I need to count my rate of change. This looks like a good point. I think this is a good point. And if I can get 2 good stares, we'll call it a day. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So up 4, run 1. So rise 4, run 1. Now in this case, I'm either going to the right one and down 4 or up 4 and to the left one. This line is indeed decreasing as it goes from left to right. It's going down. So that means it's going to be a negative rise over run. And then our y-intercept. That's our function. Again, it can be y equals, it can be f of x equals, all the same difference. Y equals mx plus b. So at that point, our y-intercept is -4 because that's where the graph touches the y-axis. And then our steps are rise 4, run 1, but it is decreasing. The line is going down from left to right, so that's why we made our slope negative. Now, this is asking which relationship represents a function with a greater rate of change than the function graphed. Rate of change in this case is that negative 4 over 1. I did not mean to give us one with both negative 4s. This is going to be your starting point. This is going to be our rate of change because that's our steps. So negative 4 is what we're trying to find something that's greater than. All right, so this is y equals a negative 6x minus 3, and I think I talked about it in our live class. So we're looking at negative 4. This would be negative 3. 0 would be somewhere over here. We could do negative 5, negative 6, negative 7, going to the left. So if our number goes to the left, in this case a negative 6, it's less than. So this one's no good. Y equals 5x plus 4. 5 is greater than negative 4. That is to the right. So this one's looking good. So we're going to leave it as an option. So we went from 0 to 2, 2 to 4, and 4 to 6. By how many? Positive 2. So negative 2, I owed you $2, and now I owe you 12. And then I owed you 22. And then I owed you 32. How much did I continuously borrow? Negative 10 all the way down. Rise over run. So negative 10 over 2. Always reduce. 2 goes into both of those numbers. 2 does go into 10 evenly. So it's going to be negative 5 over 1. Or in this case, our slope is a negative 5. Just to go full circle for practice, when x is 0, that's our y-intercept. So this equation is going to look like negative 5x minus 2. So if I was to graph it, I would go start at negative 2, count down 5 into the right one, down 5 into the right one to make sure my line is decreasing because we have a negative slope. Negative 5 is not greater than negative 4. Again, it's going in that wrong direction. It's going in the left direction. Last but not least, make sure you have multiple answers. So D's out. I'm going to go from negative 3 to 1, 1 to 5, and 5 to 9. Negative 3 to 1 might slow you down. 1 to 5, hopefully we know. 4, 4, 4. Now 16 to 0, positive 16 to 0, 0 to negative 16, negative 16 and negative 32. We're losing again. So that's going to be a negative 16 because I had $16. I now have none. Negative 16 because I owe you 16 and now I owe you 32. Rise over run. So y is always on top. Negative 16 over 4. This one again can be reduced. 4 of those go into negative 16. And it goes in there 4 times. And a negative positive gives us a negative, which is going to give us a negative 4 for our slope. Don't be tricked. This is not your y-intercept. This is your x-intercept because this is where y is equal to 0. So x-intercept. That means I didn't go up and down. I just went over to the right one. That doesn't help us with writing equations, but it does get you some bearings if you wanted to go graph this bad boy. All right, so we know it's going to rate of change is negative 4. I need to know where x is 0. So again, we could use a point and try to solve it. Or if I tried to extend my table, negative 3, 16, be negative 2, negative 1, 0. Each one is going to lose 4. So that's going to be 12. Lose 4 more is going to be 8. Lose 4 more is going to be a positive 4. And then if I was to go to the next one, I lose 4 more. That's 0. And that's that x-intercept you see in your table. So where x is 0, x was here, and we were just extending our table. We kind of took this chunk and made it go by 1s instead of by 4s. So when x is 0, we have a y-intercept of 4. So our equation is y equals negative 4x plus 4. Now, this is not the same line as the one drawn, but it does have the same slope. What do we know about same slope? What kind of lines are these? These are parallel lines. So this line would be parallel to the line that we had initially graphed at the top. So it will be parallel to the line we initially graphed at the top. So the one that does have the greater rate of change is our B with that positive 5x. All right, guys, practice makes perfect. See you next time.